Hi everyone, welcome to my channel. So in the previous video we have started with the important functions of NumPy. So in this video we are gonna continue with that. So without further delay, let's start. So these are the functions that we discussed in the previous video. Now let's start. Now first thing, suppose I have a array. Okay, so let's create a demo array. Okay, np array, and then over here I give a list. Okay, so now I have an array. Now I can add 1 to the total. Okay, so now if I add 1 to the NumPy array, 1 will be added to all the values of the same array. Okay, so let's see. So you can see 1 becomes 2, 2 becomes 3, and all the others also are increased by 1 because I have added 1 over here. Now if I would have added 8, the change would have been similar. Okay, now like addition we can also do subtraction. Like I write a minus 5, so we get the value as expected. We can also multiply it. So let's see, a star 2, so all the values are multiplied by 2. We can also add powers, so for that I'll give 2 asterisks and then 2, as in I am squaring it. So now you can see all the squares are present. This is the square of 1, of 2, of 3, of 4, and of 5. Okay, so I hope you are understanding what I am trying to say. Now this is not restricted to 1D, we can go to higher dimensions as well. Now suppose I create another matrix. Okay, so let's say I write np dot diag. Okay, because in diag we can, in diagonal matrix we can clearly see the product. Okay, the product in diagonal matrix is nothing but the diagonal elements are squared. Okay, if we square the diagonal matrix, so then over here I am gonna give 5. Now we have our diagonal matrix. Now if I square it, then only the diagonal elements are gonna become the square and all the other elements are gonna be 0. Okay, so let's see. Now I have taken diagonal matrix over here because it is very easy to visualize. So now you can see the diagonal elements have been squared and all the other elements are 0. So this means that we can multiply two NumPy arrays with each other as well, and we can also multiply it with some number if you want. So let's say 5, and 5 is multiplied to all the numbers. Okay, so you see we can add, we can multiply, we can subtract, we can divide, we can perform all mathematical operations on a NumPy array, and each of that operation will be applied to each element. Okay, and if you are multiplying two NumPy arrays, then it will be considered as a matrix. Okay, and then matrix multiplication will be done, the same matrix multiplication that we have been taught in standard 5 or 6. Okay, so now this is not the only method to multiply two matrices. We can also write a, then a dot, then dot dot a. Okay, so now the output is same as we did in a cross a, so you can infer that both are same things. Dot a means it is a cross in between. Now over here dot is means it is coming from vector background. If you know vectors, there are two types of multiplication in vectors, that is cross product and the dot product. Okay, so over here this dot refers to the dot product. Okay, so I hope all these things are making sense to you. Now like we have seen this, we can also perform logical operations like logical and, logical or, logical not. Okay, so let's see. Now suppose I have a NumPy array. Okay, and I call it np dot array, and then I create 1 comma 1 comma 0 comma 0. Okay, so this is as in true true, false false. Okay, so to force it as true true, false false, we will use dtype. We already know about dtype, we have seen in the previous video, and make it bool. Okay, and now if I press X. So you can see we get true, true, false, false, as that means that in place of 1 we get true, in place of 0 we get false. Okay, and now suppose I create another array in the same method, and np dot array, and then over here I write 0 1 1 0, then again d type is gonna be bool. So we get another boolean type array. Now let's perform logical AND to it. Okay, so I'm gonna write np dot logical AND. Okay, and then over here we write x comma y. So let's see what is the output. So the output is false, true, false, false. So what it does is it matches the corresponding values and gives the corresponding answer. Means the 0 index of array x and 0 index of array y, AND operation was performed between them, and then the output is in the 0th index of the result. Okay, so true and false is false, so we get false. True and true is true, so here it is true. False and true is false. False and false is false. So you are understanding how it goes. Okay, now we can also use logical OR. X comma y, and you can see true, 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 false. Now you can apply the operations in between these two array and see that the output is gonna be this. Now let's see for logical NOT. So np dot logical NOT, and then a single array, and we get the output. So logical NOT, what basically means is it will reverse the value. So if it was true over here, we are getting false, and if it was false, then we are getting true. So that is the use of logical NOT actually. So I hope you understand. Now we can concatenate this as well if we want. So suppose I write np dot logical OR, and then over here instead of x comma y, I want x comma reverse of y, means y not. So for that I'm gonna write np dot logical not y, and let's see the output. So we get true, true, false, true. So what actually happened was that the values of x were performing OR operation with the y not values, and then we would get this output. Okay, so you can draw a truth table and see for yourself. Okay, so you see how we concatenate more than one methods in NumPy. Okay, so I hope this part was clear as well. Now the next part is performing comparison operations. Okay, so suppose I again have x as np dot arange 1 to 10 with a step size of 1 x. Let's see. Okay, and then we have y as np dot, let's say I give array, and it is gonna be 6 comma 7 comma 3 comma 4 comma 9 comma 1 comma 2 comma 20 comma 6 comma 8. So let's count 1 2 3 4 5 6 7 8 9 3 6 9. So the numbers are even. Now let's perform equal operation. Okay, so let's see. So now if I write x equal to y, let's see the output. So you can see the output is false, false, true, true, false, 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 false. Means it is similar to logical AND, OR, and NOT. It will means perform the operation on corresponding values and give the answer on the corresponding index. So I hope you understand that the 0th value of x array is performed with 0th value of y array, and the answer is in the 0th value of the answer variable. Means if we store it in a variable, so that will be our answer variable. Okay, now similar to equal to, we have greater than equal to, we have less than equal to, we have only greater than, we have only less than, we have not equal to, and means all the other basic operations that we have, we can use them on NumPy arrays. Okay, and we can also concatenate them. Okay, so I hope you understand what I'm trying to say. So now let's continue. Now this is our Y array. I want the sum of all the values. So what I'm gonna do is I'm simply gonna write np.sum and then Y. So now the sum is given. Okay, so if you will add all the values, you will get 64 as the answer. Now we can also get the minimum value, means the minimum value of the array. So for that I write np.min Y. So the minimum value is 1, it is present over here. Okay, similarly we can get max, np.max Y, and then the output is 20, it is present over here. Okay, now similar to this we have more functions, like I write np.argmin. Okay, so what it is gonna do is instead of returning the value, it is gonna return the index. Okay, so let's see. So the index is 5. Let's see, 0, 1, 2, 3, 4 and 5. So yes, we are again getting 1. Now similarly max should return 6. Let's see. So I write np.argmax Y, and the output should be 6, and we get 6. So means we are completely able to understand what is happening over here. Okay, so now let's perform statistical functions. Okay, again we have a Y array. Now I wanna know its mean. So what I'm gonna do is I'm gonna write Y dot mean, and it is gonna return the mean. Okay, so that is 7.111, something around that. Okay, so now if you see x, okay, so you can see that 1 plus 9 is 10, 2 plus 8 is 10, 3 plus 7 is 10, 4 plus 6 is 10. So like 40, 45, and then 45 when divided by 9 will be around 5. So when we get the mean of x, the output should be y, 5. So let's see, x dot mean, and the output is 5, which means that the mean function is correct, and like we are able to understand what mean basically is and how to get it from a NumPy array. Okay, now similar to mean we have median. So I write np dot median. Okay, and then I write y inside it. So then the output is 6. So what median basically does is it arranges your array in ascending order and then gives the central value. Okay, so now our x array is already in ascending order, so if I apply median to it, 5 should be the output. Let's see, np dot median y, and the output is 6. I'm sorry, 1 2 3 4 5 6 7 8 9 4 4, then output should be 5. Okay, I'm sorry, I gave y over here by mistake. If I give x, then the median is 5. Okay, so median is also understood. Now suppose I have like 2D array. Okay, so then what we can do is we can give a axis. Okay, so let's create a 2D array. I'm gonna create a z is equal to np dot array, and then 1 2 3 4 5 6 z, and we get a NumPy array. Now let's find the median. Okay, so I'm gonna write np dot median z comma axis, and axis is equal to -1. So -1 means last axis, or I can also give 1 over here, which means row. So I get 0.2, 0.5. Now let's understand this. Okay, so I'll open my notebook. Now the array we had was 1 2 3 4 5 and 6. Okay, Now these are our rows and these are our columns. Okay, so now in rows the axis is 1 and in column the axis is 0. So now over here you can see that the axis is 1, so that means the calculation will be done with according to the row. Okay, so that means that this row will have one median, this row will have another median, and then let's say they are x1 and x2, then this is our result array. Okay, which in this case over here 1 2 3 the median is nothing but 2, 4 5 6 the median is nothing but 5, so our output is gonna be 2 comma 5, and we can see the same over here. Okay, so I hope you understood. Now we can do the same thing for mean as well. Okay, and we can also find the standard deviation. Okay, so we can simply write x dot std as in the standard deviation, and we get the standard deviation. Okay, so I hope this part is clear as well. So the last thing I want to discuss in this video is about all and any. Okay, so now suppose, okay, so I already created an array with boolean values, right? Yes, I created an array x, so let's do that again. So we have a boolean array x, and I also created for y. Okay, let me get that. Yes, so this is y. So these are the two arrays. Now we have np dot any. Okay, and in any I write x. Okay, so let's see the output. The output is true. Now np dot any means that if any value from the array x is true, then the output will be true. So means it is very similar to logical OR. Okay, and if I write np dot and, not and, sorry, np dot all x, then it is gonna be false, because all is very similar to logical AND. All the values of the array x needs to be true, then only np dot all will be true. If it occurs a single false also, then the output is gonna be false. Okay, so I hope you are understanding what I am trying to say. It is very similar to logical OR. Okay, and this is very similar to logical AND. Okay, so this was it. So I hope you understood whatever we discussed in this video. In the next video we are gonna discuss about broadcasting in NumPy. Okay, so see you in the next video. Thank you.